Welcome to Study Loop.
All right, so in this question, we have a 1 molar solution of copper nitrate in a beaker, and it has a copper electrode in it. And then we have a tin sulfate, a 1 molar tin 2 sulfate solution, and it has is in a beaker, and it also has a tin piece of metal in it. The metals, the beakers are connected by a salt bridge, and a wire connects to a voltmeter, and it connects the 2 electrodes. So in question A, we want to know which electrode serves as the anode and which serves as the cathode. So in order to figure this out, let's look at our 2 reactions. We have copper 2 plus it would be 2 electrons, and that's making the copper. On the other half reaction, we have Sn2 plus, again plus 2 electrons, and it's going to the tin. So what we need to do is look up the electric potentials on these guys and figure out what's being oxidized and what's being reduced. So the reduction potential for copper is a positive 0.34 volts, and the reduction potential for the tin is a negative 0.14 volts. So the question is, which one is being oxidized and which one is being reduced? Whichever one is more positive, so we want a larger positive value on a reduction potential list, that is the substance that is going to be reduced. Whichever one has the smaller positive or actually has a negative value, that's our substance that is going to be oxidized. If we want a spontaneous reaction, we want the reduction minus the oxidation to be a positive value. So in this case, in order for E cell to be a positive value, this would have to be the reduction, and this would have to be the oxidation. So in terms of the electrodes, the trick to remember is consonant, consonant, vowel, vowel. Keeps writing that. Consonant, consonant, vowel, vowel. Reduction occurs at the cathode, and oxidation occurs at the anode. So our cathode is where the reduction will occur, so that will be our copper metal, and the anode is where the oxidation occurs, and that is going to be the tin metal. In question B, we want to know which electrode gains mass and which one loses mass as the cell reaction proceeds. So we have our anode, we have our cathode. At the anode, remember, oxidation is occurring. So what's happening is tin is going to Sn2 plus 2 electrons. So the anode itself is actually changing from tin metal to ions floating around in the solution. So it is losing mass. So the anode, the tin, is losing mass. Whereas at the cathode, we have copper ions going to copper metal, so they are plating onto the cathode. You're getting extra copper mass on there, so this is gaining mass. All right, in part C, we want the overall equation. So we are just adding these guys together, remembering to flip this one because it's going to be oxidation. So we have Cu2 plus and that is an aqueous solution, plus Sn, and that is our electrode, so that is a solid, yields Cu solid plus Sn2 plus. And it is balanced as written. Finally, in part D, what is the EMF generated by the cell under standard conditions? So the E cell standard is going to be the E reduction minus the E oxidation. And that's going to be equal to the 0.34 is my reduction potential for the reduction half reaction, minus the potential for the oxidation half reaction, which is a negative 0.14 volts, and I get 0.48 volts.